Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. E2 elimination rate depends on the accessibility of the beta hydrogen atoms and the stability of the transition state. In E2 reactions, the rate is governed by the number of available beta hydrogens and the ease with which the base can abstract them, as well as steric factors around the carbon bearing the leaving group. Structure identification. A. 2-bromo-2-methylpropane, tertiary alkyl bromide CH3, Br, CH3 with an additional CH3, i.e. CH3, 3CBr. Actually from the image it is CH3, Br, CH3 with two CH3 groups, making it a tertiary bromide, tert-butyl bromide. It has 9 beta hydrogens, but is highly sterically hindered around the central carbon. B. 2-bromopropane, secondary alkyl bromide CH3, Br, CH3. It has 6 beta hydrogens and moderate steric hindrance. C. 1-bromopropane. Weight CH3, Br appears to be 1-bromoethane or ethyl bromide based on the image CH3, Br, a primary bromide. It has fewer beta hydrogens and least steric hindrance. Step-by-step reasoning. 1. E2 reaction rate increases with increasing substitution of the substrate because more beta hydrogens are available and the transition state is stabilized by hyperconjugation alkene stability. 2. Tertiary secondary primary in E2 reactivity under normal, non-bulky base conditions because the greater number of beta H atoms and more stable alkene product formed. 3. Therefore, A. Tertiary, B. Secondary, C. Primary, giving the order ABC. Why other options fail? Option A. CBA, this is the SN2 order, not E2. Option C. BAC, incorrect, tertiary should be faster than secondary in E2. Option D. CAB, incorrect ordering entirely. Therefore, the correct answer is B. Therefore, the correct answer is option B.